In a previous course, you probably looked at the limit of sine h over h, or sine x over x. When you look at the graph of this function, it definitely looks like the function wants to go to the value of 1. If you zoom in closer, you'll actually notice that there is no value there because when x equals 0, h equals 0, this is an indeterminate form on the graph, right? So you can actually look at it as the limit of the function. Where are those values wanting to go? And that limit is 1. So graphically, that's how we can look at it. However, it's always nice to think about what you would do algebraically to see that the limit is. And here we use a really interesting strategy where we look at the original limit and we say, how could we write that limit as a difference quotient so we can interpret it as a derivative? Well, sine of 0 plus h is the same as sine of h, and subtracting sine of 0 is actually the same as subtracting 0. So we could look at these two expressions as equivalent. Now, why are we rewriting it this way? Because we know that when we write a limit that is f of x plus h minus f of x all over h, that is a derivative. So what we've done is we've rewritten this expression as a derivative. And if we look at f of x as sine, and the point at which we're taking the derivative is 0, this expression actually becomes cosine of x at x equals 0. So another way of looking at this limit as h approaches 0 of sine h over h is cosine of h, which actually equals 1.